All right, so let's look at these problems. So here we need to simplify, and we've got a radical with a 4 index times a radical with a 2 index. If you look very carefully, this without a number, that's a 2, right? So we're just going to multiply these together, but first we're going to transform them into having the fractional exponent, which makes it easier. So I'm going to take everything the way it is written, right? X to the 5th, y. And then it's written one time like that on the inside, and it has an index of 4. And this is going to be multiplied by xy cubed, written one time like that on the inside, and with an index of 2. That's always the way you're going to transform that. This is usually going to be 1. It's very rarely another number, even when you have an exponent here. Because we're not separating them, we keep the exponent with the variable and write that it's written one time. Okay, so now we're just going to multiply the way that we know how with exponents. So this will be x 5 over 4, y 1 over 4, x 1 over 2, y 3 over 2. Okay, so we need this set and this set to have the same denominator. The easiest thing to me is going to be to multiply these by 2 over 2. So we would end up with, we change that around, change our denominators. We end up with x 5 over 4, y 1 over 4, and then 2 times 1 is 2, so x 2 over 4, and then y 2 times 3 is 6, so 6 over 4. So now we can combine our like terms. So I have x and x, 5 over 4 and 2 over 4. That's going to be x 7 over 4. And then I have y 1 over 4 and 6 over 4. That's going to be y 7 over 4. So that would be your solution. X 7 to the over 4 and y to the 7 over 4 for that problem. Next problem. All right, so now we're going to use similar triangles to find C and D. So here's C and here's D. So first we need to draw a similar triangle. So here is a 60-30 right triangle. And this is 60. We're going to make our angles in the same locations just so we remember. This is going to be 1, 2, square root of 3. I remember the base is 1, and then you just count around counterclockwise. 1, 2, 3. Or I guess that would be clockwise, wouldn't it? But the 3 is a square root of 3. And I remember that because 3 squared is 9. So I ignored the zeros and say 3 squared is 9, or square root of 9 is 3. And then that reminds me that this has the radical sign on it. So here's our similar triangles. Now I just create proportions and solve. So I'm going to start with the hypotenuse, 2 over 5. I'm going from the similar to the new. Then you'd have the base would be 1 over c, and then your height would be square root of 3 over d. Now we just set up proportions. 2 over 5 equals 1 over c, and 2 over 5 equals square root of 3 over d. 2c equals 5, so c is equal to 5 over 2. 2d is equal to 5 times the square root of 3, so d is equal to 5 times the square root of 3 over 2. Easy peasy. You've got to know and memorize your similar triangles. This is the base dimensions of every 60-30 right triangle. You have a length of 1 here. This is going to be multiplied, this 1's going to be multiplied by a factor of 2 here, and by a factor of the square root of 3 here. That's going to be the relationship between these lengths. Always, always, always in a 60-30 right triangle. Okay, so you want to know how to use that. And proportions with another 60-30-90 right triangle. Okay, next problem. All right, in this problem, we have a 45 degree right triangle, which means that these two are going to be the same length. So M and N are going to be the same. That also tells me that there's a couple of different ways you could solve it, but similar triangles is the way we're told to solve it. So I'm going to create my similar triangle here. This is going to be the same, which means these are always going to be 45. And these are both 1, and this is square root of 2. That is the relationship between those numbers, right? Okay, so another way to check your values here, and I should have told you on the previous problem, you can always take this and do a Pythagoras theorem. 1 squared plus 1 squared is equal to the hypotenuse squared. 1 times 1 is 1, 1 times 1, so that's 2. It's equal to h squared. You unsquare both sides, right? And if we go back and look at the similar triangle here, we get 1 squared plus square root of 3 squared is equal to h squared. This is going to be 1, and 3 times square root of 3 times square root of 3 is 3. H squared, right? 4 equals h squared. Square root of both of those, 2 is the value of h. So if you remember Pythagoras theorem, you can always check to make sure you have everything in the right place, that the numbers that you remember are on the right sides or on the correct sides, right? And that helps you only getting the length of these sides correct in regards to that they are both sides. Just remember that you have one base. There's only one base on a triangle, right? And that's it. And then that will remind you to put the square root of 3 on the height. Okay, back to this problem. So we're going to, we can ignore this now. We don't need this at all. It doesn't help us solve the problem. Then we're going to set up our proportions just like before. So we have square root of 2 over 5. Same, these are the hypotenuses. And then we have 1 over n and 1 over m. We know n and m are going to be the same value. So because they are congruent sides, because it's a 45-45 triangle, we really only have to solve one of these proportions because m is equal to n. So I'm just going to do square root of 2 over 5 is equal to 1 over n. That means 2 times the square root of n is equal to, I did that backwards, didn't I? N times the square root of 2 is equal to 5. So if I divide both sides by square root of 2, okay, I get that n is equal to 5 over the square root of 2, but we cannot leave it like this because we cannot have a radical in the denominator. So we multiply both sides by square root of 2, or both sides of the fraction, not sides of the equation. We multiply this fraction to conjugate it. N is equal to 5 times the square root of 2 over 2. And since m is also equal to that, we just put that out there also. This would go in both blanks. 5 times square root of 2 over 2. The answer for both m and n. Let's look at the next one. So again, we have another 45-45 right triangle. So we need to have our similar triangle. This is the same as this. It's a right triangle. So this is going to be 1, 1, square root of 2. Okay, so I am looking at 1 over square root of 3. Actually, let me just set up my proportions. So then I'll have square root of 2 over b and I'll have 1 over a, because I'm going with this triangle in the numerator and this triangle in the denominator. And the sides are the same sides in each fraction. So let's solve for b. 1 over square root of 3 is equal to square root of 2 over b. So I got square root of 6 is equal to b. That was pretty straightforward. So square root of 6 is the length there. So now I'm going to solve for a. 1 over square root of 3 is equal to 1 over a. So that's a, and that's square root of 3. So a is square root of 3. There's your answer. And by the way, you didn't have to solve that to see that, because these are congruent. This and this, they're the same thing. You could have just typed in square root of 3 without even thinking about it. And you would have been right? Because this is the same thing as this one. Those are equal because of these congruency marks. Next problem. All right, so again, we have another isosceles triangle where these two sides are the same. So we already know the value of y. The value of y is 3 because it's the same. That little tick mark tells us this is 3. We don't have to do any math, but we can go ahead and draw our similar triangle where this side is equal to this side. So 1 and 1, this is a right triangle, and this is square root of 2. So the only thing we have to calculate is z. So I'm going to look at the sides I have numbers for. That'd be 1 over 3 equal to square root of 2 over z. Let me make that look a little bit more like a 2. Okay. So z would be equal to 3 times the square root of 2. Because I multiplied this. There's your answer. 3 times the square root of 2. Done. Quick and easy. Next problem. All right, this one's from lesson 80. The number of macaws varied inversely. So that's your formula. The number of macaws varied inversely. So that's going to be constant over whatever's next. The number of apes squared. This is your formula. Now we're going to apply it to find out what our constant k is. When there were 4 macaws, so 4 macaws, there were 10 apes. How many macaws were there? This is the next part. This is after we find the answer. So what we're going to do, excuse me, I'm sorry. We're going to go ahead and do this calculation. 4 is equal to k divided by 100. We know how to get rid of that. We multiply everything by 100 on both sides. So 400 is equal to k, because this cancels and this is 400. So this is our constant. So now we will put this back into this problem. M is equal to 100 over a squared. How many macaws? So the macaws is going to be our variable, so we leave the m. When there were only 2 apes, so 2 squared. So that's going to be macaws is equal to 100 divided by 4. M is equal to 25. Okay? All right, that's how you would solve that problem. And I think that's the last one you sent me. Let me double check. Yep, that's the last one. If you have any more questions, please feel free to ask. I will see you tomorrow, hopefully.